Hello student, in this video I am going to continue from the last video, that is about uh, testing. We are discussing about testing phase of system analysis and design. So here the first topic in testing, that is unit testing. That is actually, we can say that unit testing is like write a little or test a little. Means whenever we write some codes, few lines of codes, we try to test that few lines of codes. Like that is why we try to go in a step by step process of testing, with every steps of coding the coding lines. So it's basically, you can say, informally incremental coding. And also with that incremental coding we are try to test the thing step by step. There might be static analysis, there might be dynamic analysis. In case of static analysis, we try to read the source code and we try to go step by step, word by word, like walking through. It's an informal presentation to others, by others members in the group might walk through the codes you have written, and then you inspect the code inspection. That is formal presentations to others. So walkthrough is informal, code inspection is formal. Automated tools checking, there might be some automated tools available that can be also used to check the code one by one line. And those automated tool checking can be also syntactic or semantic errors finding, or also departure from coding standards. Means suppose you are writing some code but it is not you are not maintaining that standard of the code, then that also can be checked using the tools. Or also you can check the semantic errors or syntactic errors using different automated tools. So this type of inspection, where we try to do statistical analysis, walking through the codes, or code inspections, which is formal one, or hand execution, means reading the source code to find the bug, like that. These are static analysis. In case of dynamic analysis, we try to go with some specific procedure, like one very important one, that is black box testing, and second one is white box testing. In case of black box testing, test the input and output behavior. We try to only understand the input and output behavior, that is black box testing. And in case of white box testing, test the internal logic of the subsystem or object. So there is a very good difference between black box and white box, is that in case of black box we don't want to know what is going on inside the code. We only try to understand what is the relation between input and output. But in case of white box, we try to understand the internal logic, whatever the logic written in the code, or whatever logic is working on in the system or in the subsystem or with the object. And third one is data structure based testing, that is data types determine the test cases. So we try to understand the test cases using different data types to understand the coding behavior with the data sets or data types, and that is why we can say it as a data structure based test. But my question is that which is more effective, static or dynamic, or both are important, or both are required, or both we try to follow both ones for more accuracy. In case of black box testing, we focus the input output behavior. If for any given input we can predict the output, then the module passes the test. So here testing is that we try to give some input and we try to predict the output. If the exact or that predicted output comes out from the codes or the programs, then we can say that module is passed the test. So almost always impossible to generate all possible inputs, test cases. Here these inputs can be also named as test cases. So there might not be possible outputs for every case of inputs for every test cases, or also there is almost always impossible to generate all possible inputs. Why? You need to find it out, because suppose you are trying to understand the behavior of some behavior of people, or emotional behavior of people through some app, and giving some uh, psychological advice using some app. So in that scenario, to give the input will be like emotional behavior, then it is almost impossible to give all types of emotional behavior of a person. So that is the scenario. That is why we might not be it might not be possible to provide all possible inputs to test. So for all possible inputs there might not be an output, means we might not give some possible inputs, because that is impossible to generate at some times. Goal is that goal of black box testing is that reduce number of test cases by equivalence partitioning. So main aim in case of black box testing is that we need to reduce the number of test cases, and just only reducing the number of cases will not help us. We need to take the very appropriate test cases only. So how can we choose those appropriate test cases, and how we can reduce the number of test cases? That is main importance or main goal. So we can do that by equivalence partitioning. So we can divide the input conditions into equivalence classes. Choose test cases for each equivalence class. Uh, Suppose there are some conditions given in the code. Depending upon that condition, we can divide the divide the inputs in different classes, and we can choose at least one test cases from each of the equivalence class. For example, if an object is supposed to accept a negative number, then we can only give one negative number, which is enough. We don't need to give more than one negative number, because one negative number will suffice the need of that object. With that object is supposed to accept only a negative number. Here again, if x equal to 3, then something. So here in this case also, in this black box testing also, this is a condition x equal to 3. So the classes will be, one case is that if input will be 3 and other input is any other than 3. So one class is when input is 3, and another class is when input is not equal to 3. So that might be any number, that might be 100, 200, 4, 5, 6. So you can give any one among them to test the code. That is the scenario of equivalence partitioning. We are creating two partitioning, or we are creating two classes of inputs, which as a whole creates one class, and only one among them will satisfy the whole class. So only one input will satisfy the whole class, and by testing one sample or one case will give the same output for any input of that class. Again, in this condition, if x greater than -5 and x less than 5, then so there will be three class. Some part will be between -5 to 5. Some part will be equal to 5 and greater than 5, and some part will be less than -5 or equal to -5. So there are three classes are there in this statement. One class is -5 x is minus 5 or less than 5, or x is greater than minus 5 and x is less than 5, that class, or x is greater than 5, that is another, or equal to 5, that is another class. So any one input or any one test cases from those classes only can be given as an input or test cases to understand the output or to predict the output. So don't need to give all the inputs in the test as a test cases to test the output or to predict the output. We can only give one input sets from every class. So that is what equivalence partitioning. So selection of equivalence class, no rules, only guidelines. So actually there is no rules of selection of equivalence classes, but only guidelines. So point is that input is valid across range of values. Input is valid across range of values. Select test cases from 3 equivalent classes: below the range, within the range, above the range. That is what it is saying in this scenario. Below the range, within the range, or above the range, if the input is a valid across range of values. Means if there is a range of values are there in case of inputs, then we can create 3 test cases, select test cases from 3 equivalence classes. And there is also a question, does this complete? Is this enough? You can go through that question. Input is valid if it is from discrete set. Select test cases from 2 equivalent class: valid discrete value or invalid discrete value. Like this one, x equal to 3, that is discrete. Then we can directly go with the valid discrete line value, or we can go with the invalid discrete value. Another solution to select only a limited amount of test cases, get knowledge about the inner workings of the unit being tested in case of white box testing. So if we go through white box testing also, we can correlate this black box testing concept, and then also it will be more clear to you. So in case of white box testing, we try to become more thoroughness, or we try to cover all the possible codes by analyzing the logics. Every statement in the component is executed at least once. So we try to execute every component in the code or in the program at least once. There are 4 types of white box testing. One is statement testing, one is loop testing, third one is path testing, fourth one is branch testing. So statement testing is actually algebraic testing. Test single statement. We try to understand the algebraic notation or algebraic right or wrong algebraic equations, like that. In case of statement testing, we try to test every single statement like that way to find out if there is any error or not in the algebraic equation or algebraic variables, like that. In case of loop testing, we try to cause execution of the loop to be skipped completely. Exception is that it might repeat the loops. Loop to be executed exactly once, loop to be executed more than once. So we try to do 3 type of testing. In case of testing, we try to find out when the loop will be skipped. Okay, so in that case, exception will be like loop might be repeated or loop might be executed. Or we try to test loop to be executed exactly once, or we try to execute the loop more than once. In the third one, path testing, make sure all paths in the program are executed. So in a program there might be lots of paths to the end point of the program. So we try to find out that every part of the program are executing. Fourth one is branch testing. Branch testing, or we can say conditional testing. In this testing, we try to make sure that each possible outcome from condition is tested at least one. Like here you can see, if I equal to true, then print yes, else print no. So our test cases is I equal to true or I equal to false. Means providing I equal to true or providing I equal to false, we can test the both branches of if and else. So here in case of loop testing, this might be a simple loop, there might be a nested loops, there might be concatenated loops, or there might be unstructured loops. Suppose this is one program. Here this is white box testing example determining the paths. This is one part of first part where we try to define the variables. Okay, this is the function, also define the function here. This is loop, while loop. Second, third is this is if statement. 5 is this function calling or a different part. So that is, and again this 4 is repeating, this part is repeating loop, and this is again branch. 7 if else condition. This is 8 part, this is 9 part. So there are different part of the program. So here you can see starting from 1.1, this is the one part, first part. Then 2 is the branch part, or you can say looping part. This is with a condition end of file. So with that looping we go to this. If the loop is ended, we will go to this point. Like here, if the loop is ended here, we can go to directly this 7 part of, or not ended, then it will go to this 3, this is if condition. Then if condition will be executed, it will go to either 4 part or 5th part, 4 or 5, true or false. Then it will go to 6 means that ending of the part. Then it will go back to 2 if the loop is not ended. Then it will go back to loop 2. If it is loop is ended, then it will go to 7. 7 is this part, if else condition. If is true, then it will go to 8. If it is not true, false, then it will go to 9. So like that way, this is the flow diagram, logical flow diagram. So finding the test cases. So for every part we try to find the test cases. So in case of starting with 1, we try to go through with any data in that state, that part, because this is only simple statements. We can go with any number of values or any number of data or any types of data. Then we start with this loop testing. Data set must contain at least one value. B, D, positive score is D, negative score is E. Then we go through this. But if the data set must contains empty, it will go through this position. That is why data set must be empty to go through C. So A, B, C, then D, E for any positive value. Then it will go to D part. For any negative value of data, it will go to this part. And again reached if either F or E is reached. So F or G is reached, then we'll go to this part. Okay, then at this looping can be constructed by testing the loop more than once. Then again this also, if test score is less than 0.0, then it will go to I part, or test score is greater than 0.0, then go to J part. These are also different test cases. Then exit. So you can see at various steps, various parts, there are different test cases we can take. So we need to find the test cases for different parts or different part of the program. So this is the example. You go through more example like this. So we'll try to go for more in the next video. If you have any doubt, please let me know. we will discuss through the Google Meet. Thank you.